In this video, we want to talk about troubleshooting neighborship formation with OSPF version 2. And that version of OSPF can be used to route IP version 4 networks. And some of these reasons are similar to the reasons we might have with EIGRP neighborship formation. For example, an interface's IP address is in the wrong subnet. We want to make sure that the interfaces on each end of a link belong to the same subnet. Something else we need to make sure of is, obviously, that the interface is administratively up. If it's shut down, we're not going to be forming a neighborship over that interface, and we want to make sure that the interface is participating in the OSPF routing process, keeping in mind that with OSPF version 2, we could use the network statement under router OSPF configuration mode to say we want any interface whose IP address is part of this IP address space to participate in the process, but that's just one way of doing it. We could go into the interface, and in interface configuration mode, we could say, I want this interface to participate in OSPF. Just because we don't see the network statement does not necessarily mean that an interface is not participating in the process. We want to make sure that the interface is not configured as a passive interface. Remember, a passive interface is not going to form a neighborship. However, that interface can still participate in the process. In other words, the network associated with that interface can still be advertised via OSPF. If we have authentication configured, authentication credentials, they've got a match between our neighbors, and we could be filtering OSPF packets. Just like we talked about filtering EIGRP packets with some sort of an access control list, we might have an ACL in place that's filtering OSPF packets. If we have different area numbers on each end of a link, a neighborship is not going to form over that link. We need to make sure that the area numbers match. And we could have a mismatch of area types. For example, the router at one end of a link might say that an area is a stub area, but the router at the other end of the link does not say that. That's going to prevent a neighborship from forming. And we also have to have timers match up. The hello timer and the dead timer. Remember with EIGRP, we said it wasn't necessary. It was a good practice, but it wasn't necessary to have the timers match up between our neighbors. Well, it is necessary with OSPF, otherwise a neighborship will not form. We should also have the same MTU, the same maximum transmission unit set for the interfaces on each end of a link. Something else to keep in mind is the router IDs should not be the same. We have to have unique router IDs. Notice on this list, I'm not saying that the process IDs have to equal. Remember with EIGRP, we said router EIGRP and we specified an autonomous system number. With OSPF, we're saying router OSPF and we give not an autonomous system number, we give a process ID. And those process IDs are locally significant. They do not have to match between our neighbors. With these potential troubleshooting targets in mind, let's go out to a live interface and see if we can troubleshoot an OSPF version 2 topology. Here's the topology that we need to troubleshoot. We don't have neighborships between all of our adjacent routers, and we want to go in and see what's going on. Let's see exactly what neighborships we're missing and which neighborships we have. We'll begin on router R1 and kind of work our way down. Let's do a show IP OSPF neighbor command. Ooh, it doesn't have any neighbors. I wonder if R2 has any neighbors. Let's do a show IP OSPF neighbor command there. It's got one neighbor. It's a neighbor with R4. Not with R3, not with R1, but it's a neighbor with R4. Okay, it's better than nothing, I suppose. Let's go to R3, do a show IP OSPF neighbor command there as well. No neighbors. And I bet I can predict what R4 is going to have based on what we've already seen. I'll bet that R4 is a neighbor only with R2. Let's do a show IP OSPF neighbor command. And sure enough, we are a neighbor with R2. Well, obviously we've got some issues here. Let's start at R1 up at the top and sort of work our way down. On R1, let's go take a look at the configuration of OSPF. I'm going to do a show run pipe to section router OSPF. Let's take a look at the configuration. Okay. Give you a moment to look at that, and then I'll go to R2, who we need to be forming a neighborship with, but are not. And let's do a show run pipe to section router OSPF on R2. I'll give you a moment to take a look at that. Now let's toggle back and forth. You might want to pause the video, and I'll just toggle back and forth a bit. This is R1. This is R2. Do you see anything that's necessarily an issue? Now notice I said necessarily an issue. We talked earlier in the course about not assuming facts that are not in evidence. Well, it's easy to jump to one or two conclusions here that I want us to be careful about. For example, notice router OSPF 10. And on R1, I've got router OSPF 1. Is that a problem? No, that's not a problem. Those are locally significant process IDs. They don't have to match. Is this a problem? I've got a network statement for my loopback interface. I've got a network statement for Fast Ethernet 0/0. It doesn't appear that I have a network statement for Fast Ethernet 0/1. That would explain, if that interface were not participating in OSPF, that would explain why I did not form a neighborship. But is this necessarily a problem? Am I necessarily saying that that interface is not participating in OSPF? No. I may have gone into the interface and told the interface to participate directly. Let's do a show IP protocols, try to get some more insight. Now look at this. It says, we are routing for interface Fast Ethernet 0/1. We're told that it is explicitly configured and it's a member of Area 1, so it is participating. However, we don't seem to be routing for that network. Something else is wrong. So let's dig a little bit deeper. Let's take a look at the OSPF interface configurations. Let's do a show IP OSPF interface Fast Ethernet 0/1 on router R1, and I'll give the same command on R2 and we'll look back and forth. Let's do a show IP OSPF interface. This time it's Fast Ethernet 0/0, and we can see things here like the router ID. We know that has to be unique. We see things like designated router. Remember that discussion from the Route Complete video course. We see our timers, the hello and dead timer. What else do we see? We see our address of this interface. We see our area. We see the OSPF network type. You might want to pause the video, and I'll just toggle back and forth between these. This is R2. And this is R1. Do you see anything that should match between these routers? It's not matching. Here's something that's concerning to me. I'm noticing on R2 I've got a hello time of 10 seconds, and the dead time is 4 times that at 40 seconds. But if I look at R1, the hello time is 30 seconds. That doesn't seem correct, does it? Let's fix that. I bet somebody has gone in and changed the hello time on router R1. So let's go into, let's see, it's interface Fast Ethernet 0/1, and I'm just going to set the hello interval to the default setting. I'll say default IP OSPF hello interval. And it might take a few seconds, but I'm hopeful that we're going to have a neighborship now. Let's do a show IP OSPF neighbor command. Great news. We now have a neighborship that has been formed over this link. We're now a neighbor with R2. There was another issue. Remember R3, it was not a neighbor with anyone. Let's go take a look at the configuration on router R3 and see if we can deduce anything. Let's do a show run pipe to section router OSPF and take a look at that configuration. Well, network 0.0.0.0 and a wildcard mask of all 255s. Is that valid? Is that going to include any of my interfaces in the OSPF routing process? Yes, that's a shortcut. We talked about this in the EIGRP as well. The network statement is not saying that I want to advertise this network via OSPF. This network is saying I want any interfaces whose IP addresses fall within this IP address space, which is all IP addresses, to participate. This is a shortcut way of saying I want all of my interfaces to participate in OSPF. So this is actually valid. Let's do a show IP protocols command again. Now there's something on screen right now, if you'll take a look at the topology, that's a bit concerning. You might want to pause the video, interrogate the topology that you see, take a look at the output of these two commands I've shown you on screen. Do you see anything that could be an issue? I'm seeing a red flag. Let's see if you can spot it, and we'll be back in just a moment to take a look at what's going on here. Did you notice in the topology Router R3 is supposed to have all of its interfaces participating in area 0, the backbone area. However, we're told that we're participating in area 1. That could be an issue. Yeah, I think we have an incorrect configuration here. Let's go in to router OSPF configuration mode for process ID 100, and let's say network 0.0.0.0.255.255.255.255, and instead of area 1, I'll say area 0. And we'll give it a couple of seconds, and hopefully we'll have a neighborship with R2 and R4. Let's see. Let's do a show IP OSPF neighbor command, and we do. Let's just confirm that R2 is a neighbor with all of the other routers. Show IP OSPF neighbor, and we are. We've taken a look at a couple of issues that prevented a neighborship from forming, and we've resolved those issues. However, just because we're a neighbor does not necessarily mean that we're exchanging all of the routes that we want to exchange. And that's going to be the topic of our next video, troubleshooting OSPF routing issues.